Math.com.
Hi, this is the first assignment for the year and the first math video for the year. I may refer to these as homework, even though I'm trying to rebrand them as learning opportunities. This assignment is based on nothing that we've done in class. We haven't been learning any math in class yet. We're working on developing our classroom culture as we've discussed. But because of that, I want you to review some computation on these first couple assignments. We're going to focus on these two division problems on this video. The videos are part of your homework, so you're expected to watch the video every time you do an assignment. Just understand that the video is not meant to do the problem for you. We will go through problem 1 together, the whole problem, but then when we start problem 2, at some point I'm going to ask you to pause the video. That'll be really obvious when it's time to do that. You click pause on the video and then you complete the problem on your own. And then when you click play, that gives you a chance to see how you did. That's the reason the videos are a required part of your homework, is because even if you had an assignment that you thought was very easy, you can watch the video and check your work. I also use the videos as a way to extend our instruction time, because we don't have a lot of class time, if we haven't discussed it yet. We will be discussing it, and so I present some ideas in the videos that we may not have time to get to in class. For example, on this one, I'm sure not too many students have trouble with long division, but rounding could be a challenge, I've noticed over the years, and so we'll talk in this video about rounding and place value, and that should help everybody. First couple of videos will be longer than normal. The videos will typically average about 5 minutes, but this one will be longer because I'm teaching you how to use the video, and I'm also going to teach you a resource after we do these two problems. And also don't forget, you can post your questions or comments on the discussion board for every assignment. So let's read the directions. For problems 1 and 2, divide, express each quotient to the nearest tenth. So this implies that we're looking for an answer in standard form, a decimal number. If we set this up using the standard algorithm, our dividend would go inside and our divisor outside. And then you ask how many 4s are in 1, 0. How many 4s are in 19? 4 4s is 16. 5 4s would be too much. 4 multiplied by 4 is 16. Subtract, you get a difference of 3. You bring down the 7. How many 4s are in 37? There are 9 4s, because 9 times 4 is 36. And now we get a difference of 1, and if it weren't for these instructions, we may want to express this as a mixed number. If you're dividing by 4, you're counting fourths. Let's just look at a very easy division problem. If I asked you what's 300 divided by 2, you wouldn't set that up long division. You would just tell me 150. Because you're not dividing when it's this easy. You're just thinking, what's half of 300? Because dividing by 2 is the same as multiplying by 1/2. Half of 300 is the same as 300 divided by 2, because every 2 halves is 1 whole. If you're finding groups of 2, you're halving the 300, and that's the definition of division. Dividing is the same as multiplying by the reciprocal. So if we're dividing by 4, we're not counting halves, we're counting fourths. And if I have a remainder of 1, I have 1/4 left over. Sometimes students, a common mistake would be to write 49.1 because there's a remainder of 1. But 0.1 is 1/10. We're not counting tenths, we're counting fourths. And so as a mixed number, it would be 49 and 1/4. But we're looking for standard form, and so we can continue our division if we simply show more of our number. 197 is the same as 197 and 0/10. I didn't just add anything to that number, I simply revealed that there are 0/10. And by doing that, we can continue with the division. We line up our decimal and our quotient, and we can ask how many 4s are in 10. 2 4s is 8. When I subtract, I get a difference of 2. I reveal the 0 in the hundreds place. It was always there, it just wasn't showing. And how many 4s are in 20? 5 exactly. 5 times 4 is 20. Now we have no remainder. If we, sometimes when you're dividing, the decimal will continue on. And if you wanted to divide to the nearest tenth, you would just need to go to the hundredths place. You wouldn't need to go any farther than that. So 49 and 25 hundredths. Now when we round it, I know you know how to round. Well, let's just talk about the way you round, and then we'll talk about why we do it that way. If we want to round to the tenths place, we identify the digit in the tenths place, which in this case is a 2, and then we look at the digit to the right of that digit. If it's 5 or more, we round that 2 up to a 3. If it's less than 5, well, then we leave the 2 at 2. But I'll explain why that's true in a minute. But that means when we round this, it will round to 49 and 3/10. Now I'm going to get you started on number 2, but at some point I'm going to ask you to pause, and you won't have to wonder when to do that. It will be really obvious. So when I ask you to pause, you've got about 3 seconds to hit pause on your video. You should complete this division on your own, then come back and check your quotient against mine, check your rounding and see how you did. So this is 569 divided by 67. I know this is also a division problem because the vinculum indicates division. Vinculum is the fancy math word for a fraction bar. The vinculum or the fraction bar indicates division, so this is the same as if I had written 569 divided by 67. So 569 is the dividend, and 67 is our divisor. So why don't you do that on your own during the pause, and you'll know when to pause. You'll see a prompt.
Paused.
So when I prompt you for the pause, all I do is I just sit here for 3 seconds to give you enough time to hit pause. And when you see the graphic, the pause signal pop up, then you have 3 seconds to hit pause on the video. So I'm assuming that you've done that, and you've now hit play, and you're trying to compare your answer to mine. 67. How many 67s are in 5? None. How many 67s are in 56? Also none. How many 67s are in 569? Nobody knows, but we can assume that there are quite a few. We know each digit has to be between 0 and 9. It's a base 10 system. There are 10 symbols from 0 to 9. And so if I go a little bit above that, just to get a quick estimate, 10 67s is 670. So 9 67s would be 600 and something, which is pretty close to 569. But I think 9 67s would be too many because that would be 540 and 63. That would take me just a little over 600. But 8 67s might be right. So let's check. 67 multiplied by 8. 7 8s is 56. Carry the 5. 6 8s is 48 plus 5 is 53. And so 8 67s is 536. When I subtract, I get a difference of 33. I'm going to do what we did in the previous problem and just reveal the 0 in the tenths place, bring it down, and line up the decimal in my quotient to keep the place value straight. How many 67s are in 330? Well, 5 60s is 300, but 5 7s is 35, so that would take us just a bit over. So it must be 4. 4 60s is 240. 4 7s is 28. So 240 and 28 is 268. I'm also modeling some mental math, so if you're listening carefully, you may get some ideas about how to do some of this computation, some of these steps more easily. I'm subtracting 8 from 0, which would give me a negative number, so I want to borrow from the 3 here, making this a 10. 10 minus 8 is 2. I can't subtract 6 from 2 without getting a negative number, so I borrow from the 100, the 300. Give me 12 here, minus 6 is 6. And so in order to round to the tenths place, I need to know what's in the hundredths place. And so we reveal the 0 in the hundredths place. And how many 67s are in 620? 8 67s gave me 536. If I have one more 67, that will be 603. So 9 67s is 603. 20 minus 3 is 17, so difference of 17, which really doesn't matter because once I have the digit in the hundredths place, I have enough information to round. 8 and 49 hundredths. identifying the digit in the tens place, looking at the digit to the right, it's definitely more than 5. So I will round up to 8.5, 8 and 5/10. Okay, that completes those two problems, but I want to show you a system that you can use. I'm also glancing at my notes to make sure I haven't forgotten anything. I don't know, if some of you play Pokemon, you may recognize this icon, this symbol. It's the bug symbol in Pokemon, but whether you play Pokemon or not, you can still use this system. So if you go to your favorite website, colbymath.com, on colbymath.com is a tab called Computation. And when you go to the Computation tab, you'll see all of these Pokemon icons. Now, this first homework assignment includes 6 of these. I think it's probably the first 6. But this is the bug icon. So if you had any trouble with whole number division and rounding, because you're going to see these type of computation exercises throughout the year, then you could go to this resource and click on that section. And when you go to that section, you'll see some strange spacing there. I'm not sure. I'll have to look at that later. But I've created another video to teach you how to do whole number division and rounding. So it's a more detailed video just to teach the algorithm or the ideas behind dividing whole numbers and rounding them. And then once you watch that video, there's all kinds of practice you can do here. Each one of these on the left is a practice sheet. And you can do, this is just something you do on your own to get better. So you can do some of the problems, all of the problems, however much you want to do, and then you go here to the corresponding key and you can check your work to see how you're doing. You can also, of course, come to tutoring. If we haven't talked about tutoring yet, I'll talk about that in class soon. So the idea behind the computation, all these different types of computation that we do throughout the year, is almost without exception, these are math skills that you're expected to have mastered by the time you arrive in 6th grade at CSN. That doesn't mean that if you struggle with some of them, you need to worry. It just means we know which things we need to work on, and so here's a resource to help you. And so I'm going to remind you about that again and throughout the year, and hopefully you'll make good use of it. So thank you for watching the first video, and I'll see you in the next one.